Good afternoon, everyone. Please let's turn off our mics and our videos. Today we are going to look at electronic and electrical systems and control. We are on page 122, but I'm going to use the slide as well so that we can understand a few theoretical aspects before we move to our calculations. So I'm going to share the slide with you. Can we all see the slide? All right, thank you. All right, thank you. When I invited you for the meeting, I said, I also included the slide on Google Calendar. I hope you went through the slide. I said, slide number 2 to slide number 6, you must go through those particular slides. So if you look in our books on page 122, page 123, it's just a revision about electronic systems and control. So there they are just showing us simple circuits there on how the circuit works, basically based on our switches, our bulbs, and our cells. When we add them together, when we put them in series, when we put them in parallel. So this is just a reminder. All right, we are going to start. Today my voice is not that good, but I'll try. All right, so our topic, this is very important, people. This particular topic is in your examination. All these things, hence I sent the slide before to say go through the slide, understand the theoretical aspect, because when we do calculations, it will become much easier for you to understand the calculations if you have the theory behind it. And also in your examination, I will not only focus on calculations, I will also give you some theoretical questions to answer. So let's look at this particular slide. There are three things which are important when we talk about electronic and electrical systems and control. The first thing is current. And I know in NS, you also do it. You also go through the following. So this is just revision, but I need to drill it in so that you understand it, because this is important. So what do we need to know about current? So they say current is the continuous movement of free electrons through the conductors of a circuit. So if you have a conductor of a circuit, so those movement of free electrons within that particular conductor, we refer to them as current flow. For example, if you have the light bulb within the house, when you make the circuit, when you switch on the switch, we say you make the circuit. When you make the circuit, you are allowing those free electrons to flow, and as they flow, they will cause the light bulb to shine. But if you break the circuit, because those electrons now are no longer moving freely, the light bulb will not shine. And then an ammeter is just an instrument that we use to measure current within a circuit. And please take note of the following. It is always connected in series with your circuit. This is very important. I will ask it in the examination. An ammeter is an instrument that we use to measure current. It is always connected in series with your circuit. and the symbol of current is capital letter I. The symbol that we use for current is the capital letter I. So the capital letter I, unit of measurement of electric current. The ampere is, or the ampere. So you will see when we do calculations, when we include the units, we are going to use capital letter A for ampere. And this is the person behind it. And you can see it is named after Andre Mare Ampere. So here, please note the following. It is important. Know the symbol for current is capital letter I, and the unit we use capital letter A when we calculate that particular unit, or when we do calculations later on. So the first one is current. The second thing that is important that you need to know about electronic and electrical systems and control is voltage. So what is voltage? The ability of a cell to produce current is called voltage. So that ability of a cell to produce current, remember we already spoke about current. You now know what is current. So that ability of a cell to produce current, we refer to it as voltage. Voltage is the electrical potential energy. Voltage is the electrical potential energy. Remember, potential energy, energy which is not moving, stored somewhere. But when you take that particular cell, maybe you put it inside a calculator or a remote control, you start to use it. Now that cell produces current. So that ability of that cell to produce current, now we refer to that as voltage. Now you are able to use it. Potential is just there, it's stored, it has the potential to do something. But once you insert it into a device and you start to use it, that ability of using it, then we call that voltage, that ability of a cell to produce the current so that that particular device that you are using can be able to work. And when it comes to voltage, it is measured in volts. So we measure it in volts. You will see when we do calculation, you can see here the symbols. We use capital letter V or capital letter E when we do calculations for voltage. And what do we use to measure voltage in a circuit? We use a voltmeter. A voltmeter is an instrument that we use to measure voltage. So here it's an example of a digital voltmeter. Note the following. With current, we said the ammeter must always be connected in series with the circuit. With voltage is different. If you want to know the voltage across the circuit, you must connect the voltmeter in parallel with the circuit. That is how you will be able to get the reading from your voltmeter. Please take note of the following. Differentiate between the two. Current, we said, always connected in series. With voltage, if you want to measure the voltage within a circuit, your voltmeter must always be connected in parallel. So those are two things you need to know. Current and voltage. The next thing that you need to know is resistance. Now we link Ohm's law and resistance. You will see when we do calculations. So resistance, free electrons move through conductors with some degree of friction. So if you have anything that opposes the flow of current, we refer to that as resistance. A simple example will be a light bulb. So a light bulb applies some friction to the flow of electrons. Hence, the light bulb is able to turn on because that friction will cause heat, and eventually that heat will be converted into light and the light bulb will be able to shine. So anything that restricts the free flow of electrons within a conductor, we refer to that as a resistor, or we refer to it as resistance. And this is just a symbol for the resistor. So resistance is measured in ohms, and we use the omega sign there when we do calculations. Always remember that resistance is measured in ohms. This is just a revision on page 122 and 123 in your book. And I know also in NS, you go through the following. Now, the symbol of resistance that we use is capital letter R. The symbol for resistance that we use is capital letter R. So a resistor slows. All right, it's fine. I will post the slide after the lesson. So a resistor slows down the flow of electrons in a circuit. Resistor slows down the flow of electrons in a particular circuit. Now let's move to the next one. Three things before we move to this one, to the equations. Three things you need to remember and you need to know. It's current, it's voltage, it's resistance. So resistance goes hand in hand with Ohm's law. You will see how Ohm's law fits in when we do calculations. Now we also have equations and we also have some rules. And I know you know the equations. Remember resistance. First, let's look at the triangle. The formulas are there. The formulas are given. We look at the bigger triangle after this one. So we have resistance, which is our resistor. We have voltage. We have current. Resistance. When we calculate the resistance, we divide the voltage and the current. As you can see here, capital letter R equal to V divided by I. So V is for voltage, I is for current. Remember, we said I, we use the letter, current, we use the letter I. We don't use C. So with resistance, we use capital letter R. So voltage, we multiply current and resistance. So voltage, it will be capital letter V equal to I multiplied by R, which means current multiplied by resistance. When we calculate the current, voltage is divided with resistance. So when you calculate the current, voltage will be divided with the resistance, and here is the triangle. And I know I'm just reminding you, because I know in NS you do this without a doubt. Now, we have circuits which are connected in series and circuits which are connected in parallel. So in grade 9, we will be focusing more on resistors or resistance. So hence here, we only focus on resistance in series and resistance in parallel. These you need to know. It's very important because when you do your calculation, this is going to assist you in order to remember how you do your calculations and how your answers should appear. So the first thing they say, when resistors are connected in series, the effect is to add more resistance to the circuit. So when resistors are connected in series, I will do the calculations just now on the board. When resistors are connected in series, the effect is to add more resistance. If you look in our book on page 122, figure 6.4, we have two lamps there. Figure 6.4 on page 122. We have two lamps which are connected in series. Remember, the lamps are also resistors. So when you have two lamps connected like that, one after the other, we say that they are connected in series. And when they are connected like that in series, their effect, it means that their effect is to add more resistance to the circuit. So they increase the resistance within that particular circuit. So that is what we mean by resistance in series. I will do an example on the board just now. Then example, the value of resistors in series. So this is the formula that we use for calculating resistors in series. So resistance in series, we say RT. T is for total. So we say resistance total. So when you do the calculation, you just say RT. You don't say RT bracket total. I'm just showing you that T is for the total. R you already know is for resistance. So we say total resistance. When we call it, we say total resistance. But when we write it, we don't say TR. We say RT. But when we call it, we say total resistance. But when we write it, we say RT. R is for resistance, T is for total. So when the resistors are connected in series, we add them one after the other. So we'll say R1 plus R2 plus R3. You add the value of the resistors, then you get your answer. So it will depend on the number of resistors that you have. If you have one resistor, it will be just R1. If you have two resistors, it will be R1 plus R2. If there are three, it will be plus R3. If you have 100 resistors in series, it will be R1 plus R2 plus R3, and so on until plus R100. Then you add them together, then you get the value of the resistance, the total resistance of the circuit. Now, we say the total resistance because if there is more than one resistor, you need to know the total resistance of the circuit. But that given as well, you can also have, with that being said, you can also calculate the value of resistor 1, the value of resistor 2, the value of resistor 3, and so on, depending on the number of resistors that you have. So this is the total resistance. You must know the total resistance of the circuit. And you can also calculate the value of resistor 1, resistor 2, resistor 3. In most cases, it will be given. Now, this is very important, hence I put a star there, about a series circuit when it comes to resistors. A resistor in a series circuit is called a voltage divider. Please, please, please remember that. It means in a series circuit, the voltage will be divided across each resistor. If you have 3 resistors, so the voltage will be divided across resistor 1, resistor 2, and resistor 3. So note that I'm always talking about 3 things: resistance, voltage, current. Hence I say these 3 things are important. So in grade 9, our focus is resistance in series and resistance in parallel. So you will be given circuits with values and you will need to calculate. So this becomes very important. Remember, when you calculate the voltage in a series circuit, when I say series circuit, I'm referring to resistors connected in series. It means the voltage will be divided across each resistor. But we will see when we do the calculations. Now we also have a parallel circuit. When resistors are connected in parallel, the effect is to reduce the resistance in the circuit. And we will do calculations to prove that. Now look at the following. When they are in series, they add more resistance. However, when they are in parallel, the effect is to reduce the resistance in the circuit. So if you want to increase resistance in a circuit, you put the resistors in series. If you want to decrease the resistance within a circuit, you connect the resistors in parallel to each other. Then example of how we do calculations of resistors connected in parallel. They say the value of resistors in parallel. Now the formula changes because the resistors are connected in parallel. We use fractions. We say 1 divided by RT. Remember, RT is for the total resistance. 1 divided by RT equal to 1 divided by R1 plus 1 divided by R2 plus 1 divided by R3, depending on the number of resistors that you have which are connected in parallel to each other. So when they are in parallel and they say calculate the total resistance, this is the formula that you use, fractions. So this tells you that you cannot run away from mathematics, especially if you want to do physical science as well next year. Now, the last part there, resistors in a parallel circuit is called a current divider. A resistor in a parallel circuit is called a current divider. Look at in a series circuit, a resistor in a series circuit is called a voltage divider, which means voltage will be divided across each resistor. However, in a parallel circuit, it is a current divider, meaning that the current will be divided to each resistor. So let's go back to resistance in series. I want to see if you are paying attention. Please, someone type for me on the side. If here they say a resistor in a series circuit is called a voltage divider, then what is current? What happens to current in a series circuit? If the statement says, remember we are talking about 3 things here. I said resistance, voltage, current. Here they are talking about 2 things here. They say a resistor, which is resistance, in a series circuit is called a voltage divider. So here we are talking about resistance and voltage. So they say the resistors are connected in series, the voltage is divided across each resistor. So what happens to current? Anyone has an idea? Current will be? Thank you, Nakisani. So current in a series circuit will remain the same. So if you are given a series circuit and they say to you, calculate the current, look at the mark allocation. In most cases, it will say 1. Common sense tells you you don't need to do the calculation. You can do the calculation, it will be 1. But you don't need to go through the process of doing the calculation. You just say current. You just take the total current that is given in that particular circuit and you write that answer. Then your reason will be current in a series circuit stays the same. Now let's go to the parallel circuit. They say resistors. Again, we're talking about resistance in a parallel circuit is called a current divider. Then what happens to voltage in a parallel circuit? What happens to voltage in a parallel circuit? Thank you. So it means voltage will remain the same in a parallel circuit. So those things are important and they will save you time, because in the examination, you just write the answer. If they say calculate the voltage in a parallel circuit, you just write the total voltage. Or you just say, yes, you write the value of the total voltage, then you provide a reason. Voltage stays the same, then you get your mark. So you don't need to go through the process of doing that particular calculation. Now, let's go to the last slide before I use the board to do the calculation. So this is just the triangle VIR. You also do it in NS. So the triangle is just to remind you that we have voltage, which is V, we have current, which is I, and we have resistance, which is R. So the triangle, if you forget the formula for whatever reason, quickly remember the triangle. Draw the triangle like this, VIR. So the triangle will remind you, if you are calculating for voltage, you simply go to your triangle, you block V. When you block V, you are left with I and R. So this means that when you calculate voltage, you multiply current with resistance. So you simply block V, then you are left with I and R. So when you calculate voltage, you multiply current and resistance. When you are calculating the resistance, again, you go to your triangle, you block R. When you block R, you are left with V and I. You can see V is on top, I at the bottom. So it means that we are dividing. So sorry, there is no division line. So it will mean R equal to V divided by I, which is voltage divided by current. When you are calculating the current, you do the same. You block I, block the current. So voltage, you divide it with resistance. And that is how you will be able to get that particular answer. Now, I'm going to move to the board and I'm going to show you calculations on the board. And if needs be, I will come back to this because when I'm calculating, I also need to refer to this, but I hope that you'll be able to remember that resistors in a series circuit, their effect is to add more resistance. So I'm gonna stop sharing the screen because I want to do calculations on the board. And all right, then please indicate if you can see the board clearly. Can you see the board clearly? All right, thank you. So we are going to start with resistance, calculating resistance. And you are going to do calculating resistance in series. So in the examination, this is how I'm going to give it to you. It's not going to be as simple as me giving you the current and the voltage and I say calculate the resistance. I'm going to make it a little bit more complicated for you because you are not in grade 8 now, you are in grade 9. So I will give you a circuit. So let's start with a simple circuit, a series circuit. Let's look at how we calculate resistance in series. So let's have our simple series circuit. So this is R1 and that is R2. So that is resistor 1 and that is resistor 2. Yes, common sense tells you, Kwanda, you should start writing notes. So let's say the value of R1 is 10. Remember the units for resistance we said is ohms. So it's 10 ohms. To simplify things, let's make them equal. Then the value for resistor 2 is also 10 ohms. So remember, when they are connected in line like this, we say that they are connected in series. So if you are given resistors like this, remember they can be 3, they can be 4, they can be 5, which is what we are going to get in the examination. I won't just give you 2. Or I can give you a combination of series and parallel, but we'll come to that later. So when they're like this, and the question says to you, calculate the total resistance. So this is just a simple circuit. We have 2 resistors. They say calculate the calculate the total resistance of the circuit. When they are in series, we said we add. And the formulas will be provided for you. So we say RT, remember R is for resistance, T is for total. So we say total resistance equal to R1 plus R2. We stop at R2. If there are 3 resistors, I will say plus R3. If there are 4, I will say plus R4, depending on the number of resistors that I am given. Then I simply take, and please, before you substitute, write the formula, because you have the tendency of just saying 10 plus 10. You are going to lose marks. I need to follow, I need to see that you understand that 10 is for R1, the other 10 is for R2. Don't just substitute. Show me the formula. Hence, I provide the formula so that you can write the formula first and show me the calculation so that I can follow that what is the 10 for. You cannot just say 10 ohms. So it will be 10 ohms plus, now the value of RT, it will be 20 ohms. If you go back to the slide, which I will post for you later, it says the effect of resistors or resistance in series when they are connected in series is to add the resistance in a second. And you can see we can prove that with a calculation. You add the two and you can see they are both 10. When you add them together, what have we done? We have increased the resistance of the second. We have two resistors which are 10 ohms. The effect of that is that they have increased the resistance within that particular second. So our resistance is 20 ohms. So that one is very simple. We all understand it. I'm not even going to waste time on it. Then I'm going to move to resistors in parallel. So I'm going to use the same values again. Now we have another circuit, but the resistors now are connected in parallel to each other. So when resistors are connected across to each other like this, we say that they are connected in parallel. Can you see the board clearly? Thank you. Then let's say this is R1 as well, and this is R2. I'm going to take the same values, 10 ohms and 10 ohms. Now, you are given resistance like this, and they say calculate the total resistance. Now, remember the formula changes, we now use fractions. So I will come this side, I will say 1 over RT. 1 over R total, 1 over total resistance, because the resistors are now connected in parallel to each other. They are across. So another thing in the examination, when I say to you calculate the total resistance of the circuit, the first thing you need to do, you need to identify if the resistors are connected in series or if they are connected in parallel. If they are connected like this in line with each other, we say they are connected in series. If they are connected across each other, we say that they are connected in parallel. Then it will be 1 over R1 plus 1 over R2. Remember, if I have the third one and the fourth one, it will be plus 1 over R3 plus 1 over R4 and so on, depending on the number of resistors that you are given. Now, 1 over 10 ohms plus 1 over 10 ohms. When you do your calculations, you are allowed to use a calculator. So in the examination, you will use your calculator. And as we proceed, I will show you a little bit later how to use your calculator. But for now, let's do it the next way. When denominators are the same, what happens to the numerators? When denominators are the same, what happens to the numerators? You add them. Thank you. So you will keep 10 ohms. We add our numerator 1 plus 1. Then it will be 2 divided by 10 ohms. Remember here is still 1 over R total. And the question in the examination will say to you, calculate the total resistance. Is this the total resistance of the circuit? Is this the total resistance of the circuit? I just need a yes or no. Is this Aibo? No. All right. Those who are saying no, what do I need to do from here? What do I need to do? Simplify. How do I simplify? I divide. They're giving me long methods. Okay. So I'm just going to do a shortcut. Like I said, later I will show you how to use a scientific calculator. So from here, what I can do, I'm cheating. I'm simplifying. I'm simplifying like you say I'm doing. So I'm saying RT divided by R1. Then I was taught in mathematics, what you do on the left-hand side, you must do on the right-hand side. So I'm turning them around. So here it will be 10 ohms divided by 2. So 1 into RT will be R total will be RT. 2 divided by 10, it will be 5 ohms. So you can see when resistors are connected in parallel, if you go back to the slide, it says that the effect is to reduce the resistance within that particular circuit. Now look at the resistors, 10 ohms and 10 ohms, but look at the total resistance, 5 ohms. So it means that we are reducing the total resistance within that particular circuit. Very important. Another way to check if your answer is correct in the examination, when they are connected in series, the answer that you get here, it must be bigger than the value of the biggest resistor that you have. So if the biggest resistor is 10, the answer that you get here must be bigger than 10. All right, people are saying they can't see at the bottom of the board. Okay, I'll rewrite this on the other side. Let me explain this first. If when they are in series, the answer that you get, we say that the value of the biggest resistor, the answer that you get here must be bigger than the value of the biggest resistor. When they are connected in parallel to each other, the value that you get must be smaller than the value of the smallest resistor that you have. So in this case, the smallest resistor that we have is 10, they are equal. So it means that our answer will be 5, will be less than 10. So I'm going to move the work here. So I'm going to move the calculation back here. From here, I said this is what we do. You simply rearrange. You take this, you turn it around, it becomes RT equal, divide by 1, equal to 10 ohms divided by 2. So what you do on the left-hand side, you do on the right-hand side. Then from here, 1 divided by RT, it will be RT. Now this is the total resistance, which is equal to 2 divided by 10. So it will be 5 ohms. So this is how we do the calculation. Remember, in mathematics, there are many methods and many ways. So it does not matter which method you use, even if you just use your calculator. But before you substitute, make sure that you write the formula before you substitute, because some steps you know that you can skip, they are not necessary. Can you see the top of the board now? All right, thank you. So from here, I said you can rearrange the following. Remember what you do on the left-hand side, you must also do on the right-hand side. So next time, I will show you how to use a calculator to do all this. So you don't have to go through all those steps. But if you are comfortable with these particular steps, you can use these steps. I do not have a problem. What matters is that you are able to get to the answer, the correct answer. So that is how we calculate the total resistance of resistors which are connected in series and resistors which are connected in parallel. Remember the following: when they are connected in series, they increase the resistance. When they are in parallel to each other, they decrease the resistance of that particular circuit. Now, I'm going to give you another circuit, then we are going to try to work out the sums together. Let's use the same values again, or maybe let's use 5. So in your examination, you will be given a circuit like this. And the first answer will always be calculate the total resistance. So quickly calculate what is the total resistance of the circuit. Switch off your mics, please. Ibite, switch off your mic. Thank you. What is the total resistance of the circuit? Thank you. The total resistance will be 10. So that is fairly simple. But in the examination, you won't get such a simple circuit. First, I said write the formula so that I can follow what you are calculating. So it will be 10 ohms. Then the next one, you are given the voltage. Remember, we said capital letter E is for the voltage. Now the next one will be calculate IT. What is IT for? What is IT for? Total current. Thank you. So quickly calculate the total current of the circuit. Calculate and tell me the total current of the circuit. What is the total current? Two. 2 watt. 2 watt, Runya. Is it 2 volts? Rehan. Can never be 2 volts. The current. We are calculating the current of the circuit. Can never be 2 ohms. In the examination, I marked that incorrect because of the units. Thank you, 2 amps, Jessica, but we use the capital letter A. Remember when we do calculations, I said if you forget the formula quickly, you can do this in your exam. Triangle, VIR. Then here, what are we calculating? The current. So you block I, total current, you are left with V divided by R. So voltage divided by resistance. Because we are calculating the total current, it means that, this is very important, it means that you must use the total voltage of the circuit and the total resistance of the circuit. Is important because it is not always the case where you use the total voltage and the total current. It depends on what you are given. So our total voltage we are given is 20 volts, and our total current, no, our total resistance, we calculated it, is 10 ohms. So 10 into 20, so it will be 2. So it means our current is 2 amps. So just to throw the spanner in the works, Adija, where are you lost? This triangle, it shows you the formula for calculating the current, the resistance, and the voltage. So what you simply do, if they say calculate the voltage, you block V on the triangle. When you block V, you are left with I and R. So meaning that V will be equal to I multiplied by R. If you are calculating current, you simply block I. When you block I, you are left with V and R. So this line will mean division. So you will divide voltage and resistance. When you are calculating resistance, you block V and you block R, then you are left with V and I. So you divide voltage and current. So this is the formula for calculating current. When we say IT, we are talking about the total current of the circuit. Then remember I equal to V divided by R. But because we are calculating the total current, it means that we must also use the total voltage and the total resistance in order for us to get the total current as the correct value. Now, to see if you are following, calculate the following. And remember what I said to you about resistors connected in series. Calculate voltage. V is for voltage. Calculate voltage. And this is how we write it. Voltage across resistor 1. So we say VR1. VR1 stands for the voltage across resistor 1. We know that the total voltage of the circuit is 20 volts. But now we want to know what is the voltage that passes across resistor 1. So quickly calculate it for me and tell me what is the voltage across resistor 1. So in the examination, this is how I will be asking the questions. I'm going to give you a circuit. You will calculate the total resistance. You will calculate the current, and you will calculate the voltage across each resistor. Okay, I'm repeating the question. We know that the total voltage of the circuit is 20 volts. Now, we want to know that we have two resistors. So it means these two resistors, they use up the entire 20 volts of the circuit. But we want to know how many volts does resistor 1 use in this circuit. And then we're going to come to resistor 2. How many volts does resistor 2 use in this particular circuit? My point exactly. People were not following. I am going to share the slide again with you. I'm seeing 10 volts, 4 volts. I'm seeing 10 volts. I'm sharing the slide with you. All right, let's go back to the slide. Let us read. What do they say about resistance in series? They say a resistor in a series circuit is called a voltage divider. Correct? So it means that the voltage will be divided across the two resistors. So I'm going to stop sharing, go to the board again. All right, so let us do the calculation. When we calculate voltage, we multiply current and resistance. So block V, then I and R. Current and resistance. Now, which current are we using? The circuit is in series. Which current are we using? Which current are we using to do the calculation? Thank you. So we use the total current. And which resistance do we use? We have 10 ohms here, we have 5 ohms there, we have 5 ohms there. Which resistance do we use? Thank you. So we use resistor 1. Why do we use resistor 1? Because we want to know the voltage across resistor 1. So we use the total current and resistor 1. So it will be 2 amps multiplied by 5 amps. So our answer, not 5 amps, 5 ohms. So our answer will be 10 volts. Now let's look at voltage across resistor 2. Voltage across resistor 2. Can you still see the board clearly? All right, voltage across resistor 2. What is the voltage across resistor 2? 10 again. Same procedure. We use the total current. We multiply it by the value of resistor 2. Why resistor 2? Because we want to know the voltage across resistor 2. So we focus on resistor 2. Then total current is 2 amps. We multiply by 5 ohms again. So the value of resistor 2 will be 10 volts. So that will be the value of our resistor 2. It will be 10 volts. Now, you can quickly check if your answer is correct or incorrect. When you add your two voltages, because we have two resistors, when you add them together, they must give you the total voltage of the circuit. Always remember that. When you add the voltages, they must give you the total voltage of the circuit. Now, one last one. Calculate current across resistor 1. What is our current across resistor 1? What is the current across resistor 1? Current across resistor 1? 70. That's impossible. So if you are saying it's 60, you are telling me that the current that you have is bigger than the total current. Current across the resistor 1 is bigger than the total current across the entire circuit. So the total the current across resistor 1 will be 2 amps. Remember what I said? You can give your reason. Current in a series circuit stays the same. So current across resistor 2, it will also be 2 amps. So this simply means that current in a series circuit stays the same. We are left with 3 minutes before the end of our lesson. I'm going to draw a circuit on the board, draw it. Then I'm going to tell you what to calculate. Then during the next lesson, we are going to do it together on the board. This time, I'm going to give you the same circuit, but a parallel one with the same values again. So this will be your homework. So quickly draw the circuit. This is what you are going to calculate for me. You are going to calculate the total resistance. When you are done with the total resistance, you calculate the total current. Then you calculate current across resistor 1 and current across resistor 2. Then you calculate voltage across resistor 1 and voltage across resistor 2. So this is your homework. Copy there. Second on the board. Remember the first one was series. Now this one is parallel. Remember the formula when you calculate the total resistance in parallel. You are going to calculate the total resistance, total current, current across resistor 1, current across resistor 2, voltage across resistor 1, and voltage across resistor 2. All right, it's 1 o'clock. Did we all copy? All right, I'll give you 2 more minutes to copy. If you have already copied, thank you very much. You can exit the classroom. Then I will invite you again next week.